We have to talk about what it means for a sequence to be bounded. I'm going to fill in that definition at the bottom. But what does it mean for a set to be bounded? Yeah.
Means that it has some upper and lower limit. Or
replacing limit with bound.
Yeah.
Yeah, what does it mean to be bounded? It means there exists an upper bound. So let's write that down. X bounded, and I'm going to focus on above, means X has, there exists an upper bound. Let's call it U. So that means there exists a U such that, what does it mean to be an upper bound on a set? Yeah.
U is greater than all members of the set.
I'll allow equal to also, just because sometimes the supremum is an element of the set. So that's what it means for a set to be bounded above. Do you think we can come up with a similar definition for what it means for a sequence to be bounded above? Yeah, let's try to write that down. Let's let xn be a sequence. Now let's start with what it means to be an upper bound on that sequence. U is an upper bound on xn if, well, what should that mean? Formally or informally, what should it mean to be an upper bound on this sequence? Yeah.
Then the value of the upper bound is going to be greater than or equal to all the values in the sequence.
Yeah, the upper bound is bigger than or equal to all of the sequence values. So let's just unpackage that a little bit. A sequence value is just something that looks like xn. So for every natural number of n, xn is less than or equal to u.
Is there a spot we should be writing this down?
Yeah, because I'm about to do that.
Oh, okay.
I just wanted to motivate it fast.
Oh, okay, all right. I just wondered if we were going to.
So a sequence an is bounded above if there exists a u that does this. So a sequence is bounded above if there exists some upper bound called u such that for all n in n, a sub n is less than or equal to u. That's all. And it should mean something pretty similar for a sequence to be bounded below. There exists a thing, it doesn't matter what name you call it, but maybe I'll call it L because Lenoir starts with the word L, letter L. A sequence is bounded below if there exists an L. Those definitions make reasonable sense, I hope. The second line was the same as the first line, but with the inequality switch. Right, a thing's an upper bound if it's bigger than or equal to all the things in the sequence. It's a lower bound if it's less than or equal to all the terms of the sequence. A sequence is just called bounded if a sub n is bounded above and bounded below. Does that make sense? These definitions seem reasonable? So here's one observation to make, which is an observation that we kind of made in the proof of convergence in the limit law regarding products. Right, there was this step where we said, well, I know that a sub n converges to a, so if I take epsilon equal to 1, I'll get a result. I found that eventually a sub n was somewhere between a minus 1 and a plus 1. We'll adopt exactly that proof to prove the following, hopefully fairly obvious sounding statement. If a sequence converges, then it's bounded. So let's try to do that. So let's let a sub n be a convergent sequence. It converges, so let's let a be its limit. eventually we want to come up with some bounds. And here's how I'll start. So by the definition of the limit, there's some big n such as for every little n bigger than big n, the absolute value of a sub n minus a is less than 1. People buy that that follows from the definition of the limit? Yeah, 1 is a positive number. I know something is true for every positive number. So I know something is true for all. All right, so let's massage that around. Do I have some rule about absolute values that lets me erase the absolute value bars from this? Or just use your intuition. If absolute value of a sub n minus a is less than 1, then what are some upper and lower bounds on a sub n minus a? Yeah. Yeah. Could you solve that for a sub n? What would you get? Yeah.
-1 plus a and 1 plus a.
Does this look like an awful lot like we found some bounds on a sub n? Yeah. So, like this, it's really tempting to say that we're done. There's a lower bound and there's an upper bound. -1 plus a. 1 plus a. So there seem to be upper and lower bounds on a sub n. But there's a problem. We needed little n to be bigger than big N for that to walk. So big N might have been like 10 trillion, and now we don't have any control over the first 10 trillion terms of the sequence, but we know something about all the terms after the first 10 trillion. So there's an issue. We're not really done. We need to deal with this. What about those numbers n for which little n is less than or equal to big N? Well, here's the thing to use. There are only finitely many things less than big N. Finitely many natural numbers less than big N. Well, finite sets have a maximum and a minimum. So let's use that. Let's write that down. Let's let little m be the greatest integer less than or equal to big N. Then that set is finite. Finite sets are bounded, so it has an upper bound. I'll call it U. A lower bound, I'll call it L. Now, I think I'm ready to declare some upper and lower bounds. Let's let U prime be the max between U and A plus 1. L prime be the min between L and A minus 1. I guess first things first. Do you believe that those probably should give the desired bounds? Yeah, and I guess let's talk about why. So pick any n. So you need to prove something is true for every natural number n. Well, that natural number n is either bigger than big N, in which case we're done, or it's less than big N, in which case it's less than or equal to n, in which case we're done. So we're done either way.
I'm not sure I followed that.
Cool. Let's say. So if the number big N, if the number little n is bigger than big N,
Okay.
then I'm in this situation.
Yeah, okay.
So I know I can get that conclusion.
Yeah, so you're like, done. Okay, right?
If that number little n is not bigger than big N,
Right.
then it's in that set.
Yeah.
That set, anything in that set is less than or equal to U and bigger than or equal to L. So it's certainly less than or equal to the max between U and something else. So let's now just write that down. Whenever you see two different bounds that walk in different times, just take the biggest of the two. Or less, at least, if you want the minimum, if you want a lower. So let's do that. So either little n is less than big N, or little n is bigger than big N. In case 1, I know that a sub n is bigger than or equal to, I think it should be bigger than or equal to L. So I know that because little l and little u are lower and upper bounds on the set. But L prime is the min between little l and something else. So it certainly is no bigger than little l. Same thing with little u. Oh, hey, does that prove Maybe I'll put this thus there. That gives me the inequality that I need. What if, in case 2, if little n is bigger than big N, then what things do I know? What do I know about little a sub n if little n is bigger than big N? Yeah.
And it's between -1 plus a and 1 plus a.
Cool. And look at that 1 plus a. Is 1 plus a less than or equal to this value of u prime?
Yes.
Yeah, it's the max between two things, so it's got to be at least as big as each thing. Can I stick an L prime is less than or equal to on the other end by similar logic?
Yes.
Oh, cool. So in either case, a sub n is somewhere between L prime and u prime. And that's exactly what it means to be bounded. We found a lower bound, we found an upper bound, so what on it? How does that proof feel? That seem pretty okay? And also, I hope pretty obvious. If a sequence converges, then it can't get big. That's all that boundedness is trying to capture. If it doesn't ever get big, then it's bounded above. If it doesn't ever get negative and big, then it's bounded below. So there's one result, which we'll refer to a bit later. So as soon as you know that something's convergent, you can be... The sloppiest thing you can possibly say is I have bounds if it converges. And sometimes that's good enough. Limits and inequalities. Let's set a sub n and b sub n and c sub n be sequences. Let's suppose a sub n is less than or equal to b sub n, a sub n converges to a, b sub n converges to b. What can you tell me about the limits of these sequences? Yeah. Yeah, I mean, they might be equal. But maybe the sequences will equal. The Squeeze Theorem, which you all recognize from calculus, and we'll prove it a few times in different guises. If a sub n less than or equal to b sub n less than or equal to c sub n, a sub n converges to a, c sub n converges to a, then what can you tell me about the limit of the thing in the middle? Yeah. Yeah. Which I've also heard stated as the two policemen theorem. If a sub n is a policeman and c sub n is a policeman, and you are stuck between those two policemen, and they are going somewhere, then so are you. This was told to me by someone who left Germany, so take that for what you will. All right. So, let's prove. So let's prove the first one first. Let a sub n, b sub n, and c sub n be sequences. The first one only refers to a sub n and b sub n. Be sequences. Assume that a sub n is less than or equal to b sub n for every natural number n. Assume a sub n converges to a, b sub n converges to b. I'm going to proceed by contradiction. So if I want to prove claim 1 by contradiction, what should I assume for the sake of contradiction? Yeah. A is greater than b. The negation of what I want to show. And here's something that's a little bit guiding. If a is greater than b, then can you give me a positive number that knows that a is greater than b?
Would it be like an arbitrary epsilon or like really more specific?
Yeah, something more specific. Since a is greater than b, what thing is bigger than 0? Yeah. Yeah. Right, and that's not like, it does follow, but it also happens that 1 is bigger than 0, but I think here is a reasonable thing to say. So if that's a positive number, I'm going to come up with a choice of epsilon. I know two limits, so I know something is true for every choice of epsilon. Let's try that choice of epsilon. I'll put it in pink, and we'll maybe have to revise it. So let's take epsilon to be a minus b. And now let's use the fact that a sub n converges to a, b sub n converges to b, to see what we can get. Nice. So, I know that a sub n converges to a. That means that there exists a big N, such that for every little n bigger than big N, a sub n minus a is less than this choice of epsilon. And b sub n minus b is less than that choice of epsilon. People happy so far? If both of those things follow, this is a jump, so we'll see if people want me to explain that in more detail. Then do all four of those inequalities follow? Let's try and get them one at a time. Let's put a little aside here. A sub n minus a absolute value less than epsilon. What does that become if you try to get rid of all the absolute value errors and maybe also solve for a sub n? Well, you would get this first, right? A sub n minus a, no absolute value errors, less than epsilon, bigger than minus epsilon. Right, that was one of the things about absolute value that we proved. You could then add a to both sides to get a minus epsilon less than a sub n, less than a plus epsilon. Hey, is one of those the inequalities that we wanted? Cool. So that's why this is true. Why is a sub n less than or equal to b sub n? Yeah, we assumed it. Assume that a sub n is less than or equal to b sub n for every natural number n. Right now we're only thinking about natural numbers n that are bigger than big N, but we also know that. Do you think b sub n less than b plus epsilon follows from something really similar to what we did with a sub n in that corner? Yeah, so maybe I won't write it. Yeah.
Didn't we, for the sake of contradiction, assume that a sub n is less than or equal to b sub n?
Not for the sake of contradiction. We just assumed it.
Did we assume that it was bigger than that, so the a sub n less than or equal to b sub n wouldn't hold?
Yeah, but we need to prove that.
Okay.
This is approximately the contradiction that we'll be getting.
Okay.
Yes. So let's try to get that contradiction now. So I know that a minus epsilon is less than b plus epsilon by this. So let's try to prove that a minus b is less than something. So if a minus epsilon is less than b plus epsilon, then a minus b is less than 2 epsilon. People with me? So a minus b is less than 2 times a minus b. A minus b is less than 2 times a minus b. Is that a contradiction? It's not, right? A number is less than 2 times that number? Is there something else I could put in that pink space that would give me a contradiction? I can put any positive number there that I could possibly want. What positive number would give you a contradiction? Yeah. Yeah. Perfect. So here's what I'll do. I'll replace that by a minus b over 2. Then, that choice of epsilon gives me a choice of big N. Since if little n is bigger than big N, then that happens, and that happens. So that happens. That means this happens. So that happens. So I now have a minus b is less than a minus b. Is that a contradiction?
Yeah.
Yeah, right. A thing is less than itself. If you wanted like a stronger contradiction, then I guess you could have divided by 4 instead of 2. But this gives a contradiction. This is a contradiction. Full sentence. This is a contradiction. So that means the thing we assumed for the sake of contradiction must be false. So, since we assumed that A is greater than B, we assumed that A is greater than B for the sake of contradiction, it must be that A is in fact less than or equal to B, which is exactly as we claimed. That argument feel okay? So, let's prove the last one. Let's prove the squeeze theorem. First, I think I'll give a false proof of the squeeze theorem. So, let's read through this false proof of the squeeze theorem. And let's see if we can figure out what's wrong with it. So, let's let A sub n, B sub n, and C sub n be sequences. Let's assume that A sub n less than or equal to B sub n less than or equal to C sub n for every natural number n. Let's assume that A sub n converges to A and B sub n converges to B. Well then, if B were the limit of the sequence B sub n, then by part 1 it would follow that A is less than or equal to B is less than or equal to A. So I guess by the trichotomy law, it would follow that A equals B. Since B was the limit of A sub n, that means, nope, B was the limit of B sub n. That means that B sub n converges to B. Does that sound like a proof to people? There is a thing that is wrong, and it's subtle. So let's go through and just line by line do the justification. These things are all sequences. That's just a part of the statement of the claim. For every natural number n, A sub n less than or equal to B sub n less than or equal to C sub n. That's an assumption. A sub n converges to A, C sub n converges to A. That's an assumption of the theorem. Let's let B be the limit of B sub n, and focus on that. Do I know that the limit of B sub n exists just by reading the statement of the squeeze theorem? It's awkward. Maybe I'll flip back to the previous page to check. Somewhere in the statement of the squeeze theorem, do I assume that B sub n converges, that it has a limit? No. So, there's a secret assumption in the proof. We secretly assumed that the limit of B sub n exists. So there's one way you could try to salvage this. You could say, okay, that means I just need to show that B sub n has a limit. If I can do that, then I'll know what the limit is by the proof that we just did. And that's certainly one way you could try to salvage it. Perhaps instead I'll say, well, we want to prove that B sub n converges to A. Well, there's like an epsilon n definition of that, right? Let's just do the epsilon n argument. And maybe we'll even try to come up with the argument on the board. So let's write down the things we know. Given A sub n converges to A, C sub n converges to A sub n less than or equal to B sub n, less than or equal to C sub n, for all n, we want to show B sub n converges to A. So if you want to prove a limit statement like that, and we're going to prove by the definition of the limit, what's the first thing that you should write down? Yeah.
If B sub n be a sequence?
Oh yeah, I guess I got this. Hello. Let B sub n be a sequence. We want to prove that B sub n converges to A. What does it mean for B sub n to converge to A? Yes?
B sub n is A?
Yes? But what does that mean? Yeah.
So for every epsilon greater than 0, there exists some place of capital N, such that for L small n greater than, or for L small n in the natural numbers, if small n is greater than capital N, the absolute value of p sub n minus a is less than epsilon.
There's the thing that you need to show. If you want to show that this thing is true, that's the first thing that you need to write in. You need to consider any epsilon bigger than 0. The next thing you need is to come up with a choice of big N. And I don't have any explicit formulas for any of the sequences, so there's no hope that big N will have an explicit formula. Do I have any assumptions here that can give me a big N? A sub n converges to A, right? A sub n converges to A, and I have an epsilon that's bigger than 0. Does that follow? And the same thing with B. And maybe I'll be a little bit sloppy. So right now those two big N's could be different big N's from each other. If they were different, I could just take the max between the two. That's an M plus N. So I can get that result. People feel okay about that? All right, so here's what I have. I let epsilon be bigger than 0. I came up with the choice of big N. Next, we should consider any natural number n that's bigger than big N. Need to show. Oh, that should be a C sub n, shouldn't it? I don't know the B sub n is going this way. Sorry about that. Yeah.
I think it's a big thing, but if you get one extra E on your need.
Yeah, I did notice that one. I decided to just do all with it. I thought about telling you that that's exactly how you spell need. I'm not going to fix it. So there's what I need to show. So let's just try to get that. So I know this, I know this, I want that. I guess I haven't used this yet, so I probably need to use this. So those are some things that you get to know. You know those things. How do you get the things you need to show? Yeah.
You sort of roll it all together, so you've got absolute value of kn minus a is less than or equal to the b1 minus a, and then less than or equal to the cn minus a, and then you know it's all less than epsilon. That's valid?
After erasing absolute values, I definitely believe that.
Okay.
So let's write that down. So I know a n minus a less than or equal to b n minus a less than or equal to c n minus a. I know that that's less than epsilon. So that's like half of it. If I could now show that like I could get a minus epsilon on the other side, I'd be done. Can I get a minus epsilon on the other side? Yeah, let's look at so we've done this a few times. Could you rewrite this without any absolute value bars anymore? Yeah.
So we know that an minus a is less than 1 and greater than negative 1.
Replace those ones with epsilons. Right, if absolute value of thing is less than other thing, that means thing is somewhere between negative other thing and positive other thing? Groovy. So does that mean I could put a negative epsilon at the other end of that?
Yes.
Do I now have bn minus a somewhere between minus epsilon and positive epsilon? So I could do this backwards. So I wasn't writing those steps. But do people feel like these ideas together give a proof of the result? Yeah.
So I might just not be tracking the notation here, but like, can we chain just all of them together because we know? So like, we have that rule where you drop the absolute values, and we know that they're all less than epsilon, and then we can drop it so we know it's between negative epsilon and positive epsilon. We just take that negative, essentially move it all the way out to one end, and then the positive all the way out the other, and then we just have the inequalities in between there. Like what we're doing here, is that what's happening?
I think I lost the exact chain of what you mean, but I think that that's exactly right.
Okay.
So let's write it down in the context of the proof. So let's do that. Let's suppose A and B and C and are sequences. Let's assume the inequality we get to assume. AN goes to A, CN goes to A. So the first thing I'm going to do is exactly what the first thing that happened there. Since AN goes to A, CN, and CN goes to A, there's a choice of big N, such that for a little n bigger than big N, those things happen. Now we'll do that thing where you get to erase absolute value bars. That means AN, well, let's write down the intervening step. AN minus A is somewhere between epsilon and minus epsilon. That look like you could solve that for A sub n? Yeah. A minus epsilon to A plus epsilon. Same thing for Cn. People feel okay so far? Finally, let's combine that with this ingredient. I now have A sub n is less than or equal to B sub n is less than or equal to C sub n. And what do I know is strictly bigger than C sub n by the line above? What can I put in that line? Well, what could I put in that blank? Oh, cool. Do I not have B sub n sandwiched between A minus epsilon and A plus epsilon? So maybe I'll add like an intervening sentence right here, though I think the proof doesn't really need it. Thus, minus epsilon is less than Bn minus A is less than epsilon, so that B sub n minus A in absolute value is less than epsilon. And now that we have the proof written, let's just make sure that it did the needed things. Early in the proof, did we consider any epsilon bigger than 0? Good. Somewhere after that, did we conjure up a choice of big N? Okay. Did we consider only little n's that are bigger than that big N? And did we then conclude that the absolute value of B sub n minus the limit is less than epsilon? Yeah, cool. There's an epsilon and that's the proof of the limit. Yeah. Well, I drew one of them, but I didn't mean to draw either of the absolute values. Minus epsilon less than bn minus a is less than epsilon, which then means the thing with the absolute value pairs happens. Yeah?
What did we do to choose n again?
We used the assumptions. So I know that a sub n goes to a and c sub n goes to a. Those are both things that let me translate from an epsilon to a big N. Since a sub n goes to a and c sub n goes to a, there exists some big N such that some stuff happens.
So we don't have a specific n, we just know that the threshold, that essentially passing the threshold satisfies those limit properties.
Yep. Because so I know a sub n has a limit, so that gives me a choice of big N. So take the threshold value for a sub n and the threshold value for c sub n.
Okay.
Groovy. So, with a few minutes left, maybe I'll give one or two options. Do people have any either on topic for today or homework questions they'd like to discuss? Any homework problems they've been struggling with?
I haven't gotten a chance to start 311.
It can be other homeworks. Yeah.
Could you know the definition of subsequential limit?
Yeah. That was. Yeah. Cool. So there's the definition. And what was the actual question then?
So I guess I'm just getting confused through the quantifiers, like the two n's. So like, are we able to just choose any epsilon and like
Yes.
I feel like problem number 3 is just an application of that definition, but I think quantifiers is kind of something else.
Yeah, so your false lines will be consider any epsilon bigger than 0, or let epsilon be bigger than 0, or anything that says you're considering anything. Then you'll need to come up with a choice of little n. So your first two lines are let epsilon be bigger than 0, let m be in big N. So yeah, you don't get to choose either of them. Both of them are universally quantified. And the way that you'll come up with that choice of little n, well, I guess it must have to do with that. Like, there's a thing that gives you a big N that tells you something. But that also tells you something about some little n's. Yeah. Oh, yeah. I don't know how legible it is. So first line is going to be let epsilon be bigger than, well, first declare everything. Let a sub n be a convergent sequence and b sub n be its limit. Then let epsilon be bigger than 0. Let big M be a natural number. And then you'll have to do something to come up with a choice of little n, which is bigger than big M, and which satisfies that conclusion. Neat. Oh, so I'm going to close with two other things. One of the other things is the midterm itself isn't for a while. There's some review material for the midterm to look at. It's a list of topics and then a long list of problems. It is much longer than the actual midterm will be. The other thing that I want to ask, so how many people are like getting together with each other on a regular basis to think about this stuff?
Unless you count Snapchat, in which case it's occasional.
Okay. So you might consider finding a time when you all can meet on the 5th floor in the seminar room, because that's a good place to work on math problems. And I'll also be on the 5th floor too. Okay.
What time would you be on the 5th floor?
Lots of times.
Okay.
Don't build this around me. Build this around you.
Okay.
If you want to like pick my office hour, then you definitely know I'm available. That's really small. I'm sorry. Yeah, looks like Friday. Oh, I thought you were most of these things back. Go for it.